This is the high pressure control valve. This one is the ICMT valve. The ICMT valve, it's used in ammonia all over the place. It's used in bigger industrials, CO2. It's kind of being replaced with the CCMT valve, but it's still, there's so many of these things around here. And so let's see what this thing does. This is the high pressure control valve. It is the one on the drop leg. I've got 24 volts on the red leg, power leg coming into it. Now on the black leg, I have a 0 to 10 volt signal coming from my analog output board. In this case, it happens to be a Danfoss 103, but it could be off of a Dixell controller. It could be off a 326A. It could be off the microthermal, the 744V board. It's a valve driver board. They're all it's an analog signal. It is a stepper, but I like to refer to this as an analog stepper, not a bipolar stepper or a unipolar stepper. And I'll show you why. Because coming right here, you see 17 and 18 coming off the controller. That's a 0 to 10 volt DC signal coming into these two pins off the yellow and green wire. All right. And so if the valve says it's open 50%, I expect right here to read 5 volts DC. If this says 48%, I expect to read 4.8 volts DC. That tells me the controller is in charge. And I want to make sure, because we want to get, as we do boosters, we want to get in the habit of looking at where the high pressure control valve is versus ambient. And so we want to make sure we're getting a good signal. Let me caution you here, though. There's a lot of people that are not paying attention to these high pressure control valves. How many times have you heard when you're talking about computers, garbage in, garbage out, right? We hear it all the time. Well, in order for the high pressure control valve to work properly, not only do I have to have the transducer, that is an input, the pressure input. I have to have that set up. I also need to make sure the temperature probe coming out of the gas cooler is not only about 6 inches out. I want to put it about 4 o'clock, 7 o'clock on the pipe, but don't just insulate it with duct tape. You want to put thermal paste is awesome, but then wrap it with Rubatex, but then get you a little piece of vinyl PVC wrap. What if you're in Miami? You know, that Rubatex will break down in 6 months. And now I'm not protected. That temperature sensor is very important in driving this high pressure control valve. So we're talking about electrical, but we got to talk about our inputs as well. So make sure you got a good input. Now, let's say the high pressure control valve's geeking out. Here's a little trick I have. To Amazon, I bought me a 0 to 10 volt, small little 0 to 10 volt or 4 to 20, I can switch signal generator. So if I'm not sure, is it the board or is it the controller or is it the ICMT itself? I can take the wires off of the 326, the iPro, the Dixell, whatever it is, and I can hook my 0 to 10 volt meter up and I can drive the signal manually, and I should see that on the face of the ICMT. And if I can do that, I can say, okay, from pin 17 and 18 on my drawing to here, I'm good. So that takes me back to the controller. That takes me to the wiring of the controller. And so that's some things I think about. How do we use better tools, smarter tools to help us cut the problem in half, right? If I have voltage here, if I hook my signal gen and nothing happens, I'm going to focus here on either the wiring or the circuit board. There's a circuit board inside of there underneath the cover, and it may be simply the circuit board burned out. All right, so I'm going to come here. This is the flash gas bypass valve. These are bipolar steppers. Real quick, I want to go through bipolar. A bipolar valve simply means, we all know how many steps. I don't care how many steps. I really never do care, because a step is a predetermined movement. When the controller, the iPro, whatever, sends a signal to it, it's a predetermined amount of movement that I have on the rotors and the stators to move that valve positively or negatively, right? And so all a step means is the predetermined, unless I'm programming. If I'm programming, I care. But as a technician, I just want to know if it works, right? So I don't care what the steps are. I'm not there to redo. There's like 10 guys in the field that can really understand PID. So if you're not that guy, leave PID alone. Let's look at the voltages. It's more the voltages. But let me show you this. This is something I find really cool and you guys can do. Of course, we can take, if we think the valve is bad, we can take each winding to ground, make sure it's not shorted. We can make sure it's not open by using our ohm meters. But if the rack is running and you don't know if this thing, you're thinking, I don't know if it's the Dixell, the 326, I don't know. And you can take your meter, put it on DC, then take your leads and go to the white and black wire. We're all using white, black, red, and green. That's just the standard. I put my meter here. If the valve is energizing and working properly and my controller is sending the proper signal, I'm going to either see somewhere between -5 and -3 volts DC. And every time that valve moves, I will see it switch from negative to positive. -3, +3, -3, +3. Now, sometimes it'll go positive. If I'm close to set point, it's not going to send a signal, so I'm rarely going to see that move. And so if I'm suspecting this wrong, I can simply go into the controller, change the set point so that I can force this valve to drive to a new position, and I will see it go -3, +3, -3, and maybe -4, maybe -5, whatever. But I can see it moving. And then I take my lead back to the red, green, and red. And I want to replicate that. I'm going to see the same thing. And if you've never done that and you're at the rack, next time you're at a stepper valve, try it. It works with the CCMT, the CCM, who works with the SERs. I do it all the time just to prove my theory because it's something you want to see. But think about it. Every time it steps, it's got a signal, and you can read that signal with your DC meter. All right. So that's just a really easy way to troubleshoot and determine if it's the output board, the 408 board, is it the 208C board? What is it? Okay.